Okay, this is 8F1. This is 8th grade function standard 1, video 1, and we are going to be talking about functions. And I'm going to have a few videos when it comes to understanding and comparing functions, but I thought it would be really important today to just talk about the definition of function and what it actually means when it comes to data points. Okay, before we move anywhere off the screen, I'd like to underline an important part about a function. It says that a function is a rule that assigns to each input exactly one output. So your inputs are your x values and your outputs are your y values. So the important part of this rule today is right in that underlined sentence. For every x that you have put in, that x is only allowed to have one output. It is not allowed to have two different outputs. And you're going to see that in the slides to come here. All right, we have a lot of terms to know. I'm going to have you write down all of them for today. There might be a few that I don't talk about, but we're gonna get to them in the next couple of videos. So let's get those down and define them. But you will not have to define them more than once as the weeks go on here. Represent the relation as a graph and as a mapping diagram, and then tell whether or not the relation is a function. So a relation is basically how your data points are compared to each other. What is the relationship that your inputs have to your outputs? And as I'm looking across here, I have all of my x's. So according to my definition of a function, all of my x's can only be matched up with one particular y value. So if I see -3, it is matched up with the output of -2. So this x, -3, is not allowed to match up with anyone else, and it doesn't. So -3 goes to -2. -2 matches up with +3. -1 goes to 4. 0 goes to -3. 0 doesn't go to anybody else as an x. And 1 goes to -1. So we don't have any repeats when it comes to your inputs. And I think one of the easier ways to see this is something called a mapping diagram. So let's take these values. These are your x's and these are your y's. And let's plot them in the mapping diagram. So we have -3. We have right here -2. My x is -1. My x is 0. These are my inputs. And my x is 1, positive. No, wait, what was that? Yep, +1. Oh, did I do that twice? Sorry about that. Hang on. So we have 0, and then we have +1. All right, now my outputs are my y values, also known as my ranges. So we have the inputs or the domains, and we have our outputs, also known as the range. And we don't have to put them in order necessarily like we did our x's, so let's just put them down the way they have them in their order. So we have -2, 3, 4, -3, and -1. And now we're going to draw arrows for the paired data, so our ordered pairs. So it says my input is -3, so my output for that will be -2. And I'll draw a little arrow. My input is -2 and my output is 3. Input -1, output 4. Input 0, output -3. Input 1, output -1. So you're going to notice here, if I'm following my definition, each x is paired up with only one y, and you can see that with one arrow going to the y's. So I would say that this relation is a function. So yes, it is a function. All right, now they want us to also graph it on a grid. So represent the relation as a graph and as a mapping diagram, which is what we already did. And we already told whether or not that it's a function. Why is it a function? It follows my definition. A rule that assigns each input, or your x, has exactly and only one output, which is your y. And all of those x's did that, so it's a function. Let's graph it on a grid. Okay, so we have -3, -2. That's my first ordered pair, -3, -2. Right there. Let's change that to purple. -2, 3. X is -2, y is +3. All right. -1, 4. Zero, -3. And 1, -1. All right. So we have graphed all of the ordered pairs. We have determined whether or not it's a function. And later on, I'm going to show you another way using what we call a vertical line test to prove that. So if we graph the ordered pairs on a graph, on a coordinate plane, we can determine whether or not this is a function based on a test I'm going to show you in a couple of slides. Excuse me. All right, example 2. Represent this relation as a graph, which is what we'll do on the next screen, and as a mapping diagram, which we can do here on the bottom. And then through whatever method you want, whatever method you want to use, you will be able to determine whether or not this is a function. And if something is functional, that means that it works. So think of some examples in life. You know, if your car is functional, that means it's going to be able to drive down the street. So it is a working item. So let's see if this is a working set of ordered pairs. Let's use the mapping diagram first. So we have all of our x's. This is an x and a y. And let's list all of them in the mapping diagram. So my x is 1, 2, 3, another 3, and a 4. Well, in a mapping diagram, I don't have to write the 3 twice for my x's. I'll show you that here. So I have 1 here, I have 2, I have 3. I don't have to write the other 3. I can. I don't have to, and I won't. And then my last x is a 4. And now let's go with our y values. I'm not going to put them in number order. I'm going to keep them as they are. So I have 2. I have 1. The next one is 0. The next one is 4. And the last one is 3. And I don't have any repeats there. They're all separate numbers, so looking good. Now in a mapping diagram, we're going to use the arrow idea to match up these ordered pairs. So the first ordered pair is 1, 2. So I'll go from 1 to 2. Then I have 2 to 1. Okay. Then I have 3 goes to 0. And then I also have 3 going to 4. The last one is 4, 3. Now, if you're thinking about whether or not this is a function, we have to revert back to that first screen that says, for every x value, it's only going to have one output, or one y value that's matched up with it. So let's check this. We're going to check it right here on the diagram. 1 has one partner, which is 2. These are my x's. 2 has a partner, which is a 1. And 3 has 2 different y values. So right there, since this x right here tells us that it's breaking our rule, it's breaking the function rule, this is not a function. And if we continued on, we can see that 4 had one output, which is 3, which was fine. But this is not a function. We can go ahead and graph them. 1, 2, 2, 1. I'm just going to memorize a couple here. So 1, 2, 2, 1. 2, 1. All right. 3, 0, and 3, 4. Whoa. 3, 0, and 3, 4. And then the last one was 4, 3. 1, 2, 3, 4, 1, 2, 3. All right, now we're going to leave that for later on when I talk about the vertical line test, which I think is coming up right here. Okay, if we graph these ordered pairs, the paired data, the relationship, we can use a vertical line. Now, a vertical line is a line that is going straight up and down to determine whether or not the relationship is a function. So if I were to take this line and just kind of move it across the grid, if this purple line hits more than one dot at a time, that would tell you that it is not a function. So it's a no-no for this line to hit more than one point at the same time. So let's go back to our other examples and see if we can come up with the same answers that we did before. Let me draw that purple line. All right, I guess that's more of a pink line. All right, so the rule is take a straight edge, run it vertically. If it hits more than one point at the same time, it would not be a function. So I just hit a point. I'm good. I only hit one point. I hit another point. I'm still good. It was 1 on the line, still 1 on the line, still 1, still 1, and I'm through my data. So I would say again, because it only had one dot on the line at a time, it is a function. So yes, according to the vertical line test. Now the second example, let's draw a vertical line. Let's slide it across to the right. All right, we're good. I hit one dot. I'm still good. I still hit one dot. And I got to this point right here. And that tells me, since there are 2 dots on my line, it is not a function. This is not a functional relationship. It is basically a broken car right now. It will not work. Not a function. All right. I saw this example on another video made by Learn Zillion, and I thought it was a really good idea, a really good thought to help kids understand what a function is. And basically it deals with a gumball machine. Your input are your x's. Your output are your y's. And if you think about a gumball machine and you have a quarter and you put 1 quarter in, You put 1/4 in the machine. That's your input. You put it in the machine. It will give you an output of 2 gumballs. Pretty good deal. 25 cents, you get 2 gumballs. If I were to put 2/4 in, I should get 4 gumballs. 3/4 in, I'm following the pattern here. Every time I put an additional quarter in, I get 2 more gumballs. So that should get me 6, and 4/4 will get me 8 gumballs. That is a functional machine. Let's say I happen to go to the same gumball machine and I put 1/4 in and I get 2 gumballs. The next day I go back to the same gumball machine, I put a quarter in and I get 3 gumballs that come out. 2/4, 4, 3/4 gets me 6. So what happened here? Well, it looks like on day 2, the gumball machine was broken. It was not functioning very well. It was not a function because I notice that my X spit out 2 gumballs and my X spit out 3 gumballs, which would mean, according to my definition, my X value had more than one different Y value. And we would call that not a function. It's a broken gumball machine. And we'll talk more about those in class. So I have some other examples we can go over, and we'll clear that up for you. In your journal, define the given terms, write a few sentences on what you learned from this video, and again, we are just starting this idea of functions. There's much more to come. I thought it would be important for you to get a feel for what a function is before we get into a lot more depth in this standard. I'll see you in class.